C2H5OH burns in air. Ethanol is in a spirit burner. We are burning. Ice is present inside a container, and a U-tube is there. Then the remaining gases passes through the lime water and the suction pump to make sure that all of the substances product move through the apparatus. That's why suction pump is there. Complete the box to name the apparatus. What we call this apparatus? That's a beaker. Explain why water collects in U-tube basically. So why the water is collected in this tube? What is the reason for that? Yeah, because the water condenses. The water, why it's of 2 marks, you have to mention the steam or the water vapor condenses or cool down. That's why 1 mark is for mentioning water vapor and the second mark is for mentioning condense or cool down. You can mention steam or you can mention water vapor, that will give you 1 mark, and condenses or cool down, that will give you the second mark. State a chemical test for the water, how we can test the presence of or check the presence of the water. So we can use cobalt chloride or we can use copper sulfate. If we are using cobalt chloride, what is the observation? Anhydrous cobalt chloride, it will turn from blue to pink. So not only cobalt chloride you will mention, you should use the term anhydrous. Cobalt chloride paper or anhydrous. So it will turn from blue to pink. Or anhydrous copper sulfate can also be used. It will turn from white to blue. What is the purpose of the suction pump? Why we use the suction pump for this experiment? Basically, a suction pump will reduce the pressure. So suction pump will reduce the pressure, and what it will do, it will force the substance, the product, to move through the apparatus. Otherwise, what will happen if there was no suction pump placed? Like if we were not having any suction pump here, as a combustion of ethanol or burning of ethanol give carbon dioxide and water vapor, so they can escape from this side as well. Some will travel, but some can escape around it. So what is the advantage of using a suction pump? As a suction pump, a pump reduces the pressure, so it will force the product to move through the apparatus. So it is forcing the product to move through the apparatus. So or make the product move through the apparatus. Predict the change seen in test tube that is containing a live water and explain your answer. We are burning ethanol, it produces carbon dioxide and water vapors, and that carbon dioxide we are passing through lime water, it will turn milky. And why it will turn milky? Because of carbon dioxide is formed during combustion or carbon dioxide is present. Or that turns milky due to the presence of carbon dioxide. Next part, a student investigated the rate of reaction between dilute nitric acid and an excess of solid magnesium carbonate at room temperature. The apparatus was set up as shown in the diagram. A small test tube containing magnesium carbonate was suspended in a conical flask. As you can see, a test tube is suspended in a magnesium carbonate is there in a test tube, and that is suspended. When we want to start the reaction, so we'll remove this, like we'll remove the thread, so the magnesium carbonate react with acid, give carbon dioxide, and that gas will be collected in an inverted measuring cylinder of maximum volume 250 cm cube. 50 cm cube of nitric acid. Yeah, the test tube will fall. Basically what happened when we remove this thread, or two ways it can be done. We can remove the thread and test tube fall, or we can, like, because what this thread is, it is movable, it's a small part, so we can lower the thread and it can mix with the magnesium carbonate, can mix with that acid. Both ways it can be done. So 50 cm cube of nitric acid was added into a conical flask. Content of a test tube were released, allowing a solid magnesium carbonate to mix with nitric acid. A stop clock started and a volume is collected and was measured every 10 seconds for 80 seconds. Use inverted measuring cylinder diagrams to record the collected volume. So can you fill up this table by using a screen annotation? You can use other space as well. You can use this side as limited space available for everyone to annotate on the screen. So you can use other part of the screen to annotate. So the volumes 0, 27, 48, 62, 65, 74, 76, this is 76, 77 and 77. So these are the volume of gas which are collected, carbon dioxide basically. Then plot the results on a grid and draw a smooth line graph. So basically what happened, it will be a curve like this. At 77 it is constant. I'm sketching a graph, I'm not plotting a graph. This is a sketch for this. The graph which the shape of the graph from the results which you obtain. One point is anomalous, circle that point on your graph. So basically what happened, when you mark these points, so all the points will not come out as identical. Maybe one of the point, I don't know which one because I'm not plotting a graph, but one of the point appear to be not in the range. So some student, what they do, they try to add that one also. This is wrong. You have to neglect that anomalous result. If any result which is not correct, you will remove that, means you will not include in your graph line, and draw a smooth line graph and circle the point which does not appear on the line. From your graph, reduce the time taken to collect 40 cm cube of gas. So how we'll work out the time taken for 40 cm cube of gas? So when the volume of the gas is 40, we will use the graph and find that time interval. State one possible source of error in this experiment and suggest one improvement to reduce this error. What is the possible source of error in this experiment? So possible source of error, your parallax error can be there because you are using like line of sight error can be there. Yeah, these are some errors as well. And another possible error or source of error, because what we are using a measuring cylinder. So measuring cylinder is not accurate in measuring the volume. So instead of measuring cylinder, we can also use a gas syringe. Here, why a burette cannot be used? Because we are collecting a gas in the measuring cylinder, that's why we cannot say burette. Burette is valid. Burette or pipette is when we are collecting a liquid, but here we are collecting a gas. So what we can do, many possible sources of error, this is one of them, that instead of connecting a measuring cylinder, you can have a gas syringe. Or parallax error in measurement, that you can mention, not all of the or some of the magnesium remain in the tube, so you should gradually release the thread so that it will react. Some carbon dioxide might dissolve in water. Yep, but some carbon dioxide dissolve in water, that is also motion, that is also leads to an error, but we cannot improve that, because the question is how it can be improved. Average rate of a reaction can be calculated using the equation volume of gas divided by time. So calculate the volume of gas collected between 10 second and 30 second, and then calculate a rate. From 10 second to 30 second, the time interval will be 20, and the volume, how to work out the volume of the gas from 10 to 30. So if this is a possible shape of the graph, this will be the possible shape of the graph. So what you will do, measure the volume at when time is equals to 10, and measure the volume when time is equals to 30, and the difference in the volume is the volume of gas collected in this interval. So that volume of the gas divided by time interval, which is 20, you will get the rate of the reaction. Student calculated the total volume of a gas collected in this reaction would be 85. Suggest and explain why actual volume of a gas collected was different from 85. Like student suggested that he should collect 85 cm cube of carbon dioxide, but practically he's not collecting. So now here you can write the answer. The volume of gas will be lower because some of the carbon dioxide dissolve in water. So practically will not collect like 85 will collect, volume will be less than 85. Here about the reactant, you cannot mention. Why you cannot mention about the reactant? Because this 85 is a value which is considered that when acid is reacting with metal, like not about reagent, it's about the gas. Sketch on the grid the graph you expect if the experiment was repeated using a lower temperature. So if you use a lower temperature, the reaction rate will be slower, the reaction will take relatively longer time to complete, so it will be less steeper. Same final product should be there, but it will be, if this was the original graph, then this will be the final. It should start from volume 0. In question 3, two substances such as solid A and solid B were analyzed. Solid A is zinc nitrate, so they give you the identity of solid A. So test on solid A, complete the expected observation. A solid A was added a distilled water and the mixture was shaken to dissolve solid A, produce a solution. Solution A was divided into 3 equal portions. Few drops of sodium hydroxide was added. When we add sodium hydroxide, and we have a zinc salt. What is the observation? So it will be white PPT. So in the beginning, it will form white precipitates. Excess of sodium hydroxide, we had more than enough sodium hydroxide. What is the observation? Precipitate dissolves to form a colorless solution. If it was a colored precipitate, then the colored solution will form. But because it's a white PPT, so white PPT dissolved to form a colorless solution. Few drops of aqueous ammonia is added. So when we add aqueous ammonia, first few drops are added, and then few drops of aqueous ammonia is added, B1. So we'll observe white PPT. And then excess of aqueous ammonia, we add more than enough aqueous ammonia. So again the white precipitate dissolved to form a colorless solution. Then aluminium foil and sodium hydroxide, this is a test for nitrate ion. Adding aluminium powder and sodium hydroxide, that's a test for nitrate ion. A mixture was heated and the gas produced was tested. What is the observation? The observation, because it's ammonia gas, normally effervescence, we use effervescence for a term when we see bubbles continuously coming out. But in this reaction, it's not like a rapid formation of the bubble. So it's a pungent gas, pungent and colorless gas, which will turn damp red litmus blue. Because aqueous ammonia or ammonia, when dissolved in water, it form aqueous ammonia or ammonium hydroxide, which is alkali. That's why it should be a damp, not a dry litmus. Tests on solid B, some of the tests and observations are shown. A flame test was carried out and it is giving a red. So red is due to lithium. Solid B was dissolved in water at dilute nitric acid and silver nitrate. This is a test for halide ion, chloride, bromide and iodide, and it is giving a yellow PPT. So which ion is present? So it is iodide ion is present. So identify solid B. It is lithium iodide. Then the planning of experiment. Iodine dissolve in two different solvents. Ethanol, iodine can dissolve in ethanol, and iodine can dissolve in hexane. Plan an experiment to find which of the solvent iodine is most soluble at room temperature. You are provided with iodine, two solvents, and common lab apparatus. So iodine is solid at room temperature, and on heating it sublimates. So what we will do, we will take equal volume, like example say 10 cm cube or 20 cm cube. So we took 10 cm cube of ethanol by measuring cylinder. Yeah, add 20 cm cube of ethanol into a beaker using a measuring cylinder. You can mention that. And transfer to beaker. Then we will add iodine, known mass of iodine by using spatula. Yeah, that's good. Add 20 grams of iodine, transfer into beaker using a spatula. Then what we will do, we will stir, because for dissolving we have to stir. And then we will filter to remove undissolved iodine. Then we will dry and reweight again. Then repeat the experiment. Yeah, dry using a filter paper. That's good. You mentioned the name of operators, the things which you are using. That's the more precise, complete answer. You can dry by using a filter paper or leave on the filter paper to dry, and measure the mass or weight and repeat with hexane. Now how we can draw the conclusion, how we can know like which one? The solvent which is having smaller quantity of undissolved iodine is the most suitable solvent. The conclusion, yeah, you can mention smaller mass of residue. You can mention that as well. Repeat experiment with hexane, keeping all the variable constant, the same initial mass, and the more mass of residue, the lesser solubility. That's also right. So this is just a experiment in which you have to plan. So important thing is, when you are planning the experiment, you should mention the specific name of the operators, use the name of operators for each step, and how you are carrying out. So this was October November 2019, paper 6, variant 1.